So, welcome back. In this video, we are going to determine the reducing agent and the oxidizing agent from the following equations. Okay, in order to do this, we have to identify first which species is oxidized and which species is reduced. This could be done by determining the oxidation state of each element in the equation, right? So, let's see. We have here zinc. This is a standalone element. That means its oxidation state is zero, right? Standalone. It doesn't form any compound, so its oxidation state should be zinc zero. So, and here we have copper sulfate, right? So, copper with the sulfate. Sulfate is 2 negative, then the copper should be 2 positive, right? Um, so, zinc here, the zinc combines with the sulfate. The sulfate group is 2 negative, then the zinc should be 2 positive, and the copper here should be 0. So what happened here? As we can see, let's see, zinc becomes zinc 2 plus. So oxidation process occurs. Oxidation happened, right? Loss of electrons happened, right? So oxidation occurred. So let's see what happened to the copper, right? Copper 2 positive, it became copper 0. So reduction process occurred. So reduction has occurred, right? So, so, so please focus with me. Um, Here, let's determine, or let me write it the um, with the red color. Okay, so zinc to zinc 2 positive, oxidation occurs. When oxidation occurs, that means this is this is reducing agent. A reducing agent is the reagent which occurs to it, huh? Which occurs to it oxidation, right? However, the vice versa occurs to the oxidizing agent. The oxidizing agent is reduced, guys, huh? The Let me write it here. This is the oxidizing agent. You know why? Because reduction happened to it. And another reason, it oxidized this zinc. It made it lose electrons. And the reducing agent, it reduced the copper from copper 2 positive to copper 0. I think you got the terms right, okay? So that was easy peasy, right? So let's look at it here. The second example, we have sodium. Um, Sodium is a standalone element. That means it didn't form any compound. That means the oxidation state of the sodium here should be 0. And what about the chlorine? Chlorine is also alone. It didn't form any compound with any other element. So it should be also it should have the oxidation state also of 0, right? However, let's look at the sodium chloride, right? So sodium here should have positive 1 charge, and the chlorine is turned into an anion, the chloride ion, and it has the oxidation state of -1. So let's look at what happens, right? So from sodium 0 to sodium positive 1. That means oxidation occurs. Oxidation. And let's look at the chlorine. When we look at the chlorine from chlorine 0 to chloride ion, chlorine -1, that means there is a reduction process happened. So here is reduction, and this is oxidation, right? So what is the oxidizing agent and what is the reducing agent? Okay, I term it in a simple way, or I try to make it simple for you. So how do you determine the reducing agent and how do you determine the oxidizing agent? If you look at it, the element or the substance in which oxidation occurs to it, it's the reducing agent. The vice versa. The opposite of oxidation, then reducing agent. You got me right? Huh? Okay. When you remember oxidation, yes, that means reducing agent. That's it. You don't have to think you don't have to think about anything else, right? And here you have reduction, right? Reduction process happened to the chlorine, right? So don't think about it much. That's an oxidizing agent. It's the opposite. Opposite of reduction, oxidizing agent. Just think about it this way, right? So actually I do it this way and it's a piece of cake. It's really a piece of cake this way. So oxidizing agent. That's it. Very simple, right? Okay. So let's look at this third example. We have here magnesium carbonate is decomposed by heat into magnesium oxide plus carbon dioxide. Let's look at the oxidation state of magnesium. It's 2 positive and the carbonate 2 negative. But we need to determine the oxidation state of the carbon here. When you determine the oxidation state of the carbon, it should be 4 positive, 4 positive, and each oxygen atom or the oxide ions here 2 negative. Okay, so let's look at the magnesium here. It's magnesium 2 positive and the oxygen 2 negative, the carbon positive 4 or 4 positive, 4 positive, and the oxide ions or the oxygen atoms here. It's not oxide ions here. Oxygen atoms here. The oxidation state is 2 negative. Look, 2 positive, 2 positive. Oxygen 2 negative, oxygen 2 negative. Carbon 4 positive, carbon 4 positive. Huh? What happened? Nothing happened. There is no any oxidation or reduction reaction happened here. Let's look here. Look here. There is nothing happened to the oxidation states of the elements. Simply, this is not a redox reaction. There is no any change in the oxidation state of any element, right? Let's look at another example. Iron, FeCl3, the chlorine atom with -1 times 3 times a 3, so it makes it 3 negative, so the iron should be iron 3 positive, ammonium with +1, hydroxide with -1. Huh? Hydroxide. Hydroxide -1 times 3 -3, so the iron should be iron 3 positive, right? And let's look at the ammonium here. Ammonium with +1, right? And the chlorine with 1 negative. Hmm? Let's look here. Iron 3 positive, iron 3 positive. Chloride, -1, chloride, -1. Ammonium, +1, ammonium, +1. Hydroxide, -1, hydroxide, +1. There is no any change. Then simply, there isn't any redox reaction happening here. That's it. Simple. Okay, then see you in the next video.